Hello everyone, welcome back to the channel. Today we're going to have a flat earth debate between QOP, the flat earther who I recently debated and it didn't go well for them, and someone who's actually sent stuff to space, Professor Philip Bell. It's going to be an interesting debate because one likes science, the other crayons, I assume. Yeah, so that's what we're doing today. I hope you look forward to the debate. Do me a favor, make sure you subscribe to the channel, you've liked the stream, and you share it with all your friends. Now, this is a live stream, which means that as a chance for people to join, I tend to play an intro, and the intro has music. And if you're watching this as a VOD, you can just skip like the next minute or so because there'll be music. You don't have to watch that. But if you're here watching live, then we've got a rule. When the music plays, you have to dance. If you don't dance, I'm going to send Daniel Pratt to your home. If you do dance, I'm going to give you a chocolate chip cookie. I promise. I will. You'll get a cookie. Start dancing.
A disk floating through space with a tiny sun.
Hello, I'm Craig, known as FTFE on these here interwebs. We're about to have a flat earth debate between Professor Philip Bell and QOP. It's going to be as fun as that sounds, I guess, if you like brain damage. Make sure you got your facepalm protection ready because that will be needed. Now, just before you switch over to the Discord, I'd like you all to do me a massive favor, hit the subscribe button, make sure you like the stream. Most importantly, share the stream. Outside of YouTube is the best place, on your Twitters, on your X's. If you could possibly hack the American military, so all of their blockade ships are just spouting radio signals about my URL, and I'm sure that's going to get some angry people in the chat. But hey, more people means more people watching, more people get to see the flat earth destruction. Right, let's do it. Let's go over to the Discord and see what is going on. We are in QOP's Discord for this debate.
Is he doing his intro?
Yes, I've just done my intro, QOP. Hello, how are we all doing? Welcome. You are live on FTFE.
So
today's debate is between Professor Philip Bell and QOP. Professor Philip Bell has a presentation. QOP has flat Earth, I assume. So that could be fun. Would you guys like to introduce yourself? Start with you, QOP. Say hello to everybody.
So I'm QOP. Follow my channel, QI, QOP, IP, bitches.
Bitches is not in the title of the channel, just in case you're wondering. And Professor Philip Bell, say hello to the folks.
Hello, everybody. I think everybody knows who I am. I'm Professor Phil Bell. I'm a physicist. I began my career as a chemist, so I've got my finger in both pies. Even as we speak, I teach both physics and chemistry. So I can help you answer any of questions that you have.
Oh, can we dive into quantum physics? I wasn't sure if you were a physicist, but that's cool.
Yeah, so I think we probably will be. So one of the things in my wheelhouse is particle physics. So this is what my presentation is pretty much about. So
Wait.
hopefully find it interesting. Now, so let's just have a bit of a chat. So, what made you think that the Earth is flat in the first place?
So first, the Apollo movies were pretty bad, and I was like, I didn't think the Earth was flat at that point. But then I saw they were faking the ISS with different, harness tricks and CGI tricks, and then I started looking into flat Earth, and I realized that they just taught us optics as being caused by a globe and balls going around you versus just optics appearing to go around you because of perspective and refraction and everything.
But you realize that the ISS is 400 kilometers, 450 kilometers away, thereabouts, and going around the Earth at around about 17,500 miles per hour. Goes around the Earth in 90 minutes. So you'd expect to get some glitches, wouldn't you? If you're trying to live stream from the ISS, wouldn't you expect that?
I'm talking about like clear harnesses, clearly augmented reality, like objects. Like, it's interesting. Even during the Artemis mission, they had like something floating in the air. They're always like showing that we promise we're in zero gravity. Here's a toy that's floating there. It's like basically like a magic show.
Well, things it's not actually zero gravity, but but yes, it's basically in free fall. And yes, things in free fall do float, though, don't they?
Well, you have to say it's not zero because their ISS is like you guys basically claim at the same time they're in zero gravity because they're floating around, but the space shuttle's in a orbital trajectory that's kind of still part of the gravitational force of the Earth.
So if the let's just say all of these things were that they were true, okay? So the craft is orbiting the Earth at, say, going around at 17,500 miles per hour. Then you'd expect it to do what it does. You'd expect things to float, wouldn't you? Isn't that what you'd expect to happen?
I mean,
you may not agree that it's doing that, but if it did it, if you did agree that it did that, then you'd expect things to float, wouldn't you? If things were in free fall, going that fast.
I think it's hard to know if you would be kind of still. There could be like a momentum that's pulling you against a certain wall that's on the exterior of like your orbit, but I don't know. It's a lot of things to consider.
Yeah, it's just physics, So you're saying it's just like if gravity were a thing, and you did accept that gravity was a thing, then that would have certain consequences. You'd expect, things would, everything that's heading to the floor, to the ground, would accelerate at the same time. You'd expect that to happen if you accepted gravity was a thing. If you accepted the physics of gravity, wouldn't you?
Well, I believe in gravity. I just don't believe in your theoretical explanation.
Well, I'm glad to hear you believe in gravity, because if you do, then you understand what free fall means then. In other words, free fall is a thing. Whether you think that's happening, if you think there's gravity, and there's gravity on the flat Earth, then you also accept that free fall is a thing. Is that correct?
Yeah, that's what gravity is.
Okay. Oh, awesome. All right. Well, we're getting on the same page. So your main thing was you didn't like the videos. You interpreted. I would say you interpreted glitches in the videography as deliberate hoaxes, as trying to trick people.
There's admittedly footage from the ISS live stream that they claim is they're using augmented reality. They're actually showcasing it, so it's not like they don't admit that they use that. There's many companies that they work with that are virtual reality companies.
Did you have that video? I've personally never heard that myself.
The one with the lady, and she makes the ball appear or whatever.
Well, that wasn't augmented reality. That was just editing tricks for a fun child's video.
Yeah, it's augmented realities. It's like, but it's live.
Yeah.
No, it
But
wasn't.
you understand that in spite of that, she told you what she was doing. She told you this isn't real. She told you
I'm not saying that. That's the one I'm talking about. There's other ones that they got caught using that same thing, and they weren't supposedly using it at that point.
Well, see, the thing about NASA is that they're very open about what they do, and they have to be. It's part of the law, actually. And so when they do create an animation or a computer graphic, they tell you that. They're actually quite open about the fact that it is. For instance, if you're watching the Artemis launch, at some stage, they would tell you that this part of what we're showing you here is an animation. What happened in India with the Chandrayaan 3, I heard lots of stuff from flat earthers saying, "Oh, look at that! That's like Atari graphics, back from back in the 80s." And you're thinking, well, of course, what happens is that the telemetry, instead of just being numbers on a board for you to try and interpret, they actually formulate that into a graphic so that you can say,
I understand that you guys didn't. I know you guys that wasn't supposed to look real. I got that. I wasn't arguing that.
You're one of the very few flat earthers who actually would admit
There's
to
plenty
that.
of flat earthers that know that wasn't supposed to look real.
Yeah. Okay.
You're talking about like TikTok flat earthers. So there's not really much we can debate about like what you believe is them getting caught in harnesses or using CGI. That's more something you got to show like on video and people can look on their own. So we should debate something else, honestly.
It does interest me about this harness. I told you I'm a physicist, so I have a pretty good idea about forces and strain and stress and stuff like that. Do you really think that in terms of what you see from the ISS, that maybe one or two thin lines can hold up the mass, say a 90-kilogram human being, the way that it seems to do? If there was a harness there, you'd have to hold a person from various points on their body in order for them to simulate what they do. What I need you to do, think about what it would take if you had to string up a person and get them to sit with their legs folded, for instance, and then turn upside down several times.
Are you arguing that a movie production company can't figure out how to make a invisible like wire that you can't see that can hold someone up?
Not like that, no.
Okay,
it's a big effort to be able to hold somebody up by a string that you can barely see, and then get them to turn around several times, to move around, to be able to turn upside down several times. That is, you need to think of that in terms of reality, in terms of what would it take to do that. So if you look at it from that point of view, what would it take to actually achieve that? And you might think, well, that's, especially in that space that you're looking at. You're looking at a pretty confined sort of space. How would that happen in that confined space?
Yeah, I mean they have plenty of ways to make that happen. I don't know how you're even arguing that. It's kind of weird that you're arguing that they couldn't do that. Honestly, there's movies like Gravity and stuff, all kinds of movies that they show people floating around.
I'm pretty sure that would be impossible. The way that the way that you see it, on that. To have that happen that easily, that would be impossible. And plus, they go past each other. That just thinking about that in terms of thin wires holding people up, try to do that with something large from your ceiling or something like that, and see what it takes. You do that with some fishing wire that's very thin, and see how easy it is to hold that up.
Okay, I'll concede. Fishing wire can't hold up an astronaut. Very good.
No, I'm talking about something that thin.
Okay, I don't really know what kind of wire they're using.
All right. Okay. I'm just trying to give you some other explanations of why you would.
So, do you believe that space-time causes gravity?
Yeah, I do. Yeah, it's the best model that we have at the moment. Yeah.
What is like the connection? What is the proof of the relationship of the space-time field causing gravity?
Well, okay. So let's just say what gravity is first. Okay, when we talk. So Earth has a gravitational field. Okay, that means that anything that's within this gravitational field is going to be affected by it. Now, the space-time creates
Most people
the
understand the concept. I was talking about what's the proof of the cause being space-time.
Well, there's plenty of proof for that. For instance, light. For instance, the clocks in a spaceship. For instance, from the perspective of people on Earth, they slow down.
Clocks.
The same clocks. Yeah. For instance, the atomic clocks. Yeah. So time actually bends. Time actually gets warped.
Okay.
So space-time the space-time model for gravity works.
Okay. Got it. So the clock. So we're talking about a cesium atom vibrating.
Yeah.
Okay. So it doesn't actually say any time on it, right? It's just an atom vibrating.
Oh, look, I don't want to go into the physics of how a cesium clock works, but...
that was quick. You want to tap out?
Yeah.
Do I get a point for that if you tap out right now?
There's no points.
Sorry?
There's no points?
No.
Yeah. Sure, well, just suffice to say the clock works, okay?
But it's not a clock, it's an atom.
It's a measuring device, is his point.
Yeah, hang on, let me... Whenever an atom produces radiation, it produces it at a steady rate. And this steady rate can be measured and used as a means of tabulating time.
Yeah, I know how the atomic clock works. I thought you didn't want to talk about it.
Okay, no, I'm just answering your previous question. Okay, look, what else did apart from what's on the ISS and what you think about the moon landing and what you think about Artemis, why else would you think the Earth is flat?
Like you just said that so you don't want to talk about the proof you said of space, about time bending.
No, let's just try and get some ideas about why you think let's pretend I know nothing about this. You tell me why Earth is flat. I know nothing. I'm just going to pretend I know nothing about it.
I'm going to tally a little point for myself on my little chart of points. But so why do I think the Earth's flat?
Yeah.
I mean, so one of the reasons is because this, when you actually look at space-time or the double-slit experiment, quantum physics, and you find out that they're actually just doing really simple things and misinterpreting them and not telling you everything they're doing and everything that's just not based on actual, empirical proof. It's just kind of like a story that they told you. Then you start realizing, well, the physics isn't real that they tell us. There's a more simple unified field theory. There's a more simple explanation for why we see everything converge at the horizon. And then when we find out, when you look at when you get into the flat versus globe debate, and you see that the globe never actually measured Earth curve, they just assume it based on like angles to stars and stuff, or like using optics and looking very far with a theodolite that's not designed to look that far. You start to realize that they actually never measured Earth curve, so it must be by default flat, because there's no reason to think sea level curves.
Okay, so all of that was about how you don't like something, not anything about why you think that it's actually flat.
Well, yeah, by
I'm talking
default.
about evidence for why you think it's why should not being a globe make it flat?
Well, because the idea that gravity like down is not kind of like parallel in everywhere, and somehow like gravity is like converging around a ball. It's just there's no reason to think that unless like they prove that's the case, because everyone else just thinks of the sky as up, Earth is down. Even the astronauts talk about us being up here. It's like in the globe model there is no up, so it's weird.
Well, that's true. So you agree that things
FTFE doesn't like that. He doesn't want you conceding that.
Yeah. No, I'm just trying. I'm trying to get out of you. I'm just trying to get out of you why you think the Earth is flat. Okay, that's all. That's all I'm trying to do. Okay. All right, and I'm happy to share with you why I think it's a globe.
Don't do it, FTFE. Oh my God, he hung himself. He said your argument's so bad.
So at this stage,
I'm streaming eating a professor on my channel. I just killed myself.
Okay, let's get on with the arguments. Not what I'm doing.
Okay, so at this stage, are you you haven't given us any evidence yet about why Earth is flat.
I mean,
all you've said is why you think it's not a globe.
Yeah, I mean, so most of the reasons I think it's flat is because I found out that it's not a globe. So I mean, I haven't like set up like a experiment to actually measure, the ground and see. I mean, it's hard. Like you can't like measuring the ground. Obviously, there's no reason to measure the ground, because it's not like flat earthers think that the ground is completely flat. It's topographical, so you wouldn't know. You basically have to see if like gravity is like plumb bobs are actually like converging. So you would have to either measure plumb bobs converging or measure sea level actually curving, which no globe and flat earthers haven't really done that. So
yes, they have.
How have globers done that?
What makes you think that hasn't happened? Do you know? Yeah, have you not heard that pylons for bridges are plumb with the Earth? Every single pylon has to be dead plumb.
Yeah, and you think they're...
Did you know that?
Okay, you're saying they converge?
Yes.
And how do you know that?
Measurements.
The distance between the bottom is shorter than the distance between the top of the pylon.
Okay. Is that something we can verify?
Even though each and every one of them is plumb by itself.
So you're saying each section there's a difference between the top and the bottom's length?
Yes.
Has anyone measured that, or is that just in the engineering
100% have measured it, yes.
Okay, can you...
For instance, example would be the Golden Gate Bridge. Look it up.
Well, I mean, I know when you look up these things, they'll tell you they are accounting for curvature, but that's kind of one of the things.
When you look it up, it'll tell you that the bottoms that the distance between the bottom of the pylon is less than at the top.
Yeah, I mean, I assume I know how the world works. I know that most of the time they're telling us that there are these globe things that are accounted for because of globe curvature in different buildings, I forget what that there's another building that people talk about a lot. CERN, I think, claims that they they level the ground to be curved or something like that, for it to be.
Yeah. They're not.
Yeah, so
they're not doing it. They're not doing it to trick flat earthers. They're not
No, I know
doing it
we
to
don't.
trick.
But see, the thing is, we don't believe that they're doing it. We just think they're saying it.
And they're saying it. They're just telling you lies. The people who measured it are saying,
Well, if the Earth was
"Oh,
flat,
I'm just
if the
going
Earth,
to tell
the Earth
you
was,
lies."
if the Earth was flat, they would be lying about the globe. So that, yeah, they would be lying.
So the people who know nothing about flat Earth, don't give a damn about what shape the Earth is, measure the distance between the bottom of the pylon and the top, and find that it's different. They just want to trick you.
No, I didn't say there's anyone actually measuring it. I would assume that they're not measuring that, and that someone's
They
just
are.
writing. Do you have a video of
measuring
someone measuring that?
They do measure it. The reason they know what the difference is because someone measured it.
Okay, but so I've never seen that. So can you enlighten me and show me a video or something of someone measuring?
I don't specifically have that evidence right now, but I mean, you can look that up, and then we can both.
I know you can look it up.
if you
You
like.
can look up, is the Earth a ball, and they'll say yes. So I know you can look up these things.
All right. Would you not be a flat earther if I could prove that to you?
No, because the bridge could be just curving for like a structural standpoint. Like
No, if I could prove to you that the pylons were plumb, and that despite that the bottom is different, the distance from the one pylon to the other at the bottom is different to the top. Would you not be a flat earther anymore if that was the case?
I guess if you could prove it to me.
Okay, that's good. Because I just had this idea, because for most flat earthers, there's no evidence that would make them change their
No,
mind.
just because maybe but there's not been any evidence. Like you just all you do is say that they.
I'm about to give you some today, so we'll see, and we'll see if you would change your mind.
Well, the proof is not them just saying it.
Okay. Tell me something. Do you think GPS is a thing?
What do you mean? Like, do I? Of course.
Well,
like,
you got it in your car. Have you got that? Have you got GPS in your car?
Yeah, everyone has GPS on their phone.
And you got it on your phone. You got it in your car. You trust it. It tells you the distance from one place to another. When you put it in, I want to go there. It says, oh well, you got to go this many kilometers, right? Or this many miles.
Yeah.
And the GPS basically gives you your latitude and longitude coordinates, doesn't it?
Oh, sure.
Yeah. Okay. Great. Okay. So we trust it, and it works just the same for you as it works for me.
Mm-hmm.
We trust the GPS. So we trust both the GPS itself, and we also trust the longitude and latitude coordinate system.
Yeah, but I don't know if the distance between those latitudes is correct.
How can it not be if we trust that it? That's what the GPS uses to be able to tell the distance between one place or another.
So the globe model, your position on
Let's
the
just
globe,
assume the Earth is flat. Forget the globe. It's flat. Let's work on a flat Earth.
right? So there's an entire map, right? It's all been mapped out. The satellites scanned everything. They know where everyone is, right?
No, I'm not even going that far. Not even going that far. All I'm saying is let's just stick with the fundamentals. Fundamental thing is that the GPS tells you the latitude and longitude where you are, and tells you the latitude and longitude of the place that you want to get to, and calculates the distance between them.
Okay.
That's how it works. And we trust that that actually does work.
I know it works. Do you know how many corrections it makes every second?
It doesn't matter. In the end, it tells you it doesn't matter what corrections it makes. It does work, right? It makes corrections because you move.
Okay, but if
As long as you move, of course, it's going to make corrections for when you move. It has to change its latitude or longitude depending on your position.
No, it's
Now-
making corrections for a lot of different things.
Yeah. Right. Now, when you so I'm trying to establish that we get us on the same page. So we both agree that GPS does work and that it does rely on latitude and longitude coordinates. That's all I'm trying to get to. We're on the same page. The more things that we can agree on, the easier to us to work out the things that we don't agree on. Okay. So now that we know that, you can see along the equator, if you pick two longitudes along the equator, the distance is greater than any other latitude that's both north and south of the equator. So in other words, the distance is greater along the equator. Well, pick a longitude and latitude coordinate along the equator, which will obviously the latitude will be 0. Pick that, and then the GPS will work out the distance between them. Pick out a longitude and latitude coordinates north or south of the equator, and you'll find that the distance will be between the same longitudes will be less than the equator.
I know what the globe model is, but how do you know that that's actually true, like in the south specifically?
You can give it a go right now if you want. This isn't something that you can't give it because we trust the system. You can actually do this yourself.
No, I know that GPS works. I know the GPS works, but just imagine a world where, like in the south, they basically the GPS was only the latitude longitude was only working in like south, like in southern continents, but not in the ocean. How would you know if it was working in the ocean?
Because people in ships, traveling over the ocean, people in airplanes have GPS.
You can actually, like when you're driving, you got an odometer. I don't think you can measure like a distance when you're in a ship. You just have to assume that the GPS is telling you the correct distance.
You think that? You think the people in the ships don't know where they are? Their longitude and latitude coordinates from the GPS?
He said you can't have a foolproof odometer on a ship.
Let's try to just keep it to QOP and Professor Phil talking, please.
So you don't think that on a ship that people have a GPS device and they can tell where they're going?
Also, this is it's like a hard thing to debate this, but the main thing is like there's in the south, like I'm assuming the continents and the land masses are all mapped correctly. I don't have a problem with that. I think there's there's problems with in the south. I believe the south is bigger, so I would assume that there's oceans that they basically take different paths. There's for the most part, the most places that you're not allowed to travel are in the south. You can look that up. Obviously at 60th degree south, you can't even go any farther. I don't even think you can get close to 60 degrees south, but so I'm sure there's an incorrect magnetic declination map that we're given, so that can also account for how they constrain like the south smaller by claiming the magnetic lines are maybe not pointed in the not going in the same direction. You could fudge you can claim that the magnetic declination lines are like this, so people think they're farther along somewhere. So there's a lot of ways that you can basically be going around a flat earth with the AE model type flat earth and they can basically sell it as a globe.
Can we get back to the fact that the distance along the equator is greater than the distance along any other two latitudes, both north and south of the equator? Right, that you can do that. You can do that yourself. It's nothing that you can't do yourself. You can do it from your computer. You can do it where you're sitting.
Well, that's not proof.
You can get the GPS. You can get the GPS location of something that's two places along the on the same longitude. At the equator, you do the same thing, say 30 degrees south, 30 degrees north, and you'll find that both those 30 degrees north and 30 degrees south are the same distance, and you also find that both of those are greater than the distance along the equator.
Okay, that's just you saying you can do it. You saying you can do it from your computer is circular because you're just claiming you could look at the model basically that you're giving from the GPS model, and that you could just verify that the model works. Like, that's not, you're not actually measuring anything. You're just cross-checking their model with their model. Does that make sense?
But we both agreed that the GPS works, don't we? We agreed with that in the first place.
But there's lots of corrections being made, so we don't know what they're correcting for.
If there are any corrections, there'll be minor corrections for perhaps for topography. I'm not talking about that. I'm talking about something that's too long longitudes that are maybe 1,000 miles apart. Right.
Okay, well,
that's what I'm saying. You can do this. You can do this yourself.
You're not providing any measurements. You're claiming that these bridges, pylons are like converging. You're claiming the south longitudes are smaller than the equatorial ones. You're just claiming these things. You're actually not providing any measurements of these things.
Well, we'll get to your claims later, but certainly we'll. I'm telling you why I believe that the Earth is a globe. Right? Okay, that's one of them. Now, I want to show you something else because time will get on, and I don't want to miss doing this. I spent a bit of time putting this together for you. So, if Craig, if you wouldn't mind putting up the first. The first slide for my video, thanks. For my presentation.
Like this one, yeah?
Yeah.
Yeah, okay, it's displaying.
Okay, all right. I'm looking at YouTube over there, and it's all right. I'll try not to concentrate on YouTube because it's way behind. Okay, all right. So the first one says that the first slide that you've got there. Just let me open mine. Okay. So the first slide says that neutrinos prove that Earth is a globe, right?
Yes.
Bro, neutrinos? We're going right to neutrinos?
I can't see what you're doing. Okay, so because the YouTube is way different. Okay, all right. So, all right, let's go to the second one. What are
hey Phil, you can double click on FTFE to see the presentation in Discord. Can you see that?
Okay. All right. Okay. Sorry, I didn't know that. All right. So if I double click on that. Okay.
Yeah.
Shut up, Wesley.
Come on. Let's not keep the soundboards out for now. Yeah, I'm displaying your presentation in Discord, Professor Phil Bell. So if you look at the Discord chat that you're in,
okay.
The main screen should be now your presentation, page 2.
I can just see you there. I can't see it. I can't see my presentation.
There's as well as the people. There should be one that says live, and that will be what your presentation is on.
Sorry, I'm a bit of a Luddite with this.
Yeah, no, you've not used Discord before.
I have it not to do this. Yeah, okay. Let me just do that. Okay, I see it now. All right, that's great. Okay. All right, so this slide says, what are neutrinos? All right, so let's go through that. Okay, so neutrinos are one of the really unusual, challenging particles in modern physics. They belong to the family of fundamental particles. So in other words, you can't break them down into anything else. They're not made of anything smaller. They're defining features that make them behave in ways that they're radically different from other everyday matter. They almost have zero mass. They do have mass, and so therefore they're affected by gravity. It's so tiny that for practical purposes it behaves as if it doesn't have mass, right? So the mass is about 10 to the minus 27 kilograms, which is about the mass of a proton. This is so small that even the most sensitive laboratory instruments wouldn't be able to weigh this like that, like we'd normally weigh something, all right? All right, so the other thing about neutrinos is they have no electric charge. So they don't carry charge. They're neither negative or positive in charge, right? They don't interact with electric or magnetic fields, okay? And that's why they don't get deflected. They don't get slowed down or trapped by matter, okay, the way that charged particles do. They just pass through everything. They pass through matter, okay? There's the other thing about it is they're extremely weak interaction with matter. So neutrinos interact only through weak nuclear force, which is the least intuitive of the four fundamental forces. The document, this is a striking comparison between neutrinos and other particles. A neutrino could pass through a light year of solid lead before having a 50% chance of actually interacting with it. Okay? This means that neutrinos can pass through planets, stars, and even entire galaxies without stopping. And because of this, 100 trillion neutrinos pass through your body every second. Okay. Why do these properties matter? Well, these properties make neutrinos perfect probes of the Earth's interior. Since they travel in straight lines and pass through all of matter, unhindered, practically unhindered, they allow us to see through the Earth in a way that no other particle can. Right? All right, so who discovered neutrinos? That was the history of neutrinos. I forgot to tell you to change the slide.
It's okay, I'm on this slide of discovery.
Okay. Oh, yeah, great. You can see there's awesome people there on that slide. Okay, and they are Wolfgang Pauli, this German scientist. He proposed that neutrinos. Yeah.
How did they discover neutrinos?
I'll just go through it with you, and then you'll see. Right? Okay. So Wolfgang Pauli he proposed that neutrino to solve a mystery in beta decay. That's where energy seemed to disappear, and Pauli famously apologized for proposing a particle that can't be detected at that time in 1930.
So he discovered it when he didn't detect it?
No, he proposed it. Okay, he saw that there was a anomaly in.
So before
let me finish this. Let me finish this, and then we'll get down to, because this isn't the most important part of it.
This is great, though. I feel like you're making my arguments for me. This is good.
Okay, sure. No problems. I'm not trying to educate you. I'm trying to educate the audience. Right, so first okay, so the first detection happened in 1956, and that happened by two scientists called Clyde Cowan and Frederick Rains. Okay, they detected neutrons at the Savannah River nuclear reactor. Okay, their experiment they had enormous shielding, precise timing, and basically a statistical analysis, right? And that was a very, very significant thing. In fact, they won the Nobel Prize for physics for doing that. And where the neutrinos come from, neutrinos are produced in different ways. For instance, the sun. The sun is the biggest producer of neutrinos. and produces by 2 by 10 to the 38 neutrinos every second. Okay, so a flux of about 65 billion neutrinos per square centimeters arrives at Earth. And these solar neutrinos travel in straight lines. They arrive almost instantly compared to light because they pass through the sun's dense interior. So light that we experience comes from, it takes a very, very long time to reach the surface of the Earth in order for us to get to see it. Whereas for neutrinos, that happens practically instantly. It also we can produce them using particle accelerators, like at CERN and Fermilab. They create neutrino beams, and that's by smashing protons into targets. And the resulting pions and kaons decay into neutrinos. These beams are deliberately aimed through the Earth. So we aim them through the Earth towards distance detectors. So we have a detector that's buried in the Earth, which is a very, very large water tank, about 50,000 litres of very, very pure water. That's buried, and they actually aim at the tanks. And this produces a blue cone, and that's how we detect neutrinos. Also, nuclear reactors produce them, right? Mm-hmm. And cosmic rays. So, right. So, if we keep going to the next couple of slides, how neutrinos interact with water in detectors. Neutrinos detectors relies on rare interaction with water molecules. Okay, and we have the Cherenkov radiation. That's where a neutrino reacts with a nucleus or electron, and it produces a charged particle that moves faster than light travels in water. So it doesn't go faster than light in a vacuum. It goes faster than light in water.
Is that cone effect visible like in normal water or just nuclear reactor water?
In pure water, just normal pure water. Okay. Right. So this creates this kind of blue light. It's called.
See that in any water?
Any water is water. So you can get heavy water, of course, which has hydrogen that has neutrons. But I'm just talking about just pure water. Okay. So all water has some heavy water.
What is the cone shape exactly? The neutrino, like kind of like going through the water?
As the neutrino goes into the water, it interacting with the water molecule produces this Cherenkov radiation cone. There's also the super Kamiokande experiment, which is 50,000 tons of ultra pure water, and detect 11,000 photo multiplier tubes, and these are sensitive to single photons, right? We've got the crucial observation neutrons came from below at night. So this is a central argument that I'm trying to make. So basically, just to cut to the chase, the sun produces neutrinos that go through the Earth, and these are detected on the other side of the Earth. That's those neutrinos that go through the Earth are detected on the other side. So in other words,
So question. So you're saying on one side of the Earth, there's the cones are like shaped in one direction, and then the other side, the direction is the other way.
No. What I'm saying is that the sun is on one side of the Earth. Let's say, for instance, let's say you're let's say you. On one side of the Earth, let's say you're in Australia, on one side of the Earth, it's sunny. So in other words, the sun is shining down. And on the other side of the Earth, exactly the antipodal side of the Earth, you can you can detect the neutrinos.
And how,
So in
how
other
do you know
words-
those? How do you know those are the same neutrinos?
Well, they are not there when the sun's not. When I'm just about to tell you how we know that. Because what you can do is you can actually follow where the sun is. So you can pinpoint where the sun is by measuring.
I let you do a lot of slides. I mean, you can't answer that question. How we know they're the same neutrinos?
He is trying to answer that question now. If you just let him get through his
Trying to answer that
sentence.
question. Just let me finish it, all right? Then you'll understand. Okay. Do you understand how an equatorial mount works?
Yes.
Okay. So in other words, if it follows the sun, eventually it'll get to the horizon. So let's say it's pointing straight up at noon, then it just follows the sun, keeps following the sun, and then it'll go below the horizon.
Are you
and
saying are you saying these cones that they're detecting, these neutrino cones or whatever, are kind of angled like a equatorial mount where they like shift with the sun?
Yes. Yeah, exactly.
Yes?
Exactly what I'm saying. Yeah. So like an equatorial mount, it'll go down below the horizon, and then start pointing into the ground, and keep pointing into the ground, and literally it's following the sun.
I got it. So like
when-
that'd be a cool proof if you guys could show that.
It is a cool proof.
So, do you have any
And yes,
pictures of these cones, or should I look it up? Because it doesn't look. You got a bunch of cartoons on you. Should I look up? I'll go look it up. I'll go look it up.
All right. While you're doing that, I'll be back in a second.
Okay, going quite well so far. Phil is explaining quite eloquently how neutrinos are great evidence for the shape of the Earth. The fact is that the sun emits neutrinos, and we can see that by the detectors and the direction that it's coming from, and the fact that during the night they come from underground, exactly where the globe model predicts the sun would be. And of course, we know the sun is in that position because the other side of the world can see it at that time. Do feel free, QOP, to look up pictures and videos of these radiation detectors. I'm sure even if you contact some places that do these experiments, they might even invite you over.
Yeah, I'm very surprised to find that there's no images of these neutrino cones.
Well, there is. You just maybe Phil didn't put them in this. Maybe Phil didn't put them in this presentation because he doesn't realize that flat earthers need actual hand holding in certain cases. But he's just explaining the process, which you can feel free to check the validity of in your own time, of course. Real Jiffy Cones became a member or upgraded their membership to Destroyers. Thank you very much. Max for 30 UE says that QOP is a coward. Oh, that's something that you two can fight about. TBL Soundwave for $2 says, I wonder how many people in this server are MAGA. I'm not going to do politics. People get mad at me. Potato Tron for $2 says, agrees with EFF Grudge. Not sure what that's about, but thank you. Bobby Two Hands for £10 says, you got it, Craig. What was that, QOP?
Flat earthers don't follow politics. We're not on either side of the fake Hegelian dialectic,
I mean, I would
system.
disagree. The majority of I've come across lots of very right-wing flat earthers, of course. Mr. Toffees became a new member. Thank you very much. Jim Daniels for $5 says, I wonder why flat earth proponents never complain about the videos from Skylab or the Soviet Union's Mir space station. Yeah, of course, because NASA ain't the only one with things in the sky. Odin's Rage, $5 Canadian, says, calmly humming, we love the Earth to stay sane. Keep doing it, dude. It's much needed. And then another new member of Flerfs Destroyer. Welcome to Destroyers. Thank you very much. Now, we have to bear with Phil. Obviously, everyone's aware of Phil's current condition, so let's just try and go easy on the professor. QOP, any questions? Anything you'd like to say to the audience now on either your channel or mine?
Yeah, so I mean, I couldn't find any images when I asked ChatGPT. Oh, wait, you asked me a different question. I'm trying to figure out, ChatGPT claims that you don't even see the cone itself. You just extrapolate the cone from seeing like a ring.
Well, ChatGPT also thinks that its name was spelt with an S, so it's not usually the best place to go to for factual information.
Well, there was nothing in this, children's slideshow, so I'm trying to figure out what.
this is very, very, very a very short summary of all of this. Okay, so
Yeah, I mean,
if you are genuinely interested in wanting to know more about this, I'll be more than happy to share what I can with you. Okay, all right. There's a lot to this.
So do you agree with what I just? Do you agree with what you agree with ChatGPT that they don't actually see cones? They're almost impossible to image these radiation cones, but they do detect a glowing ring inside the water. They don't. That's how they extrapolate that's caused by this cone.
They not only can see the cone, but they can actually see which direction it's pointing at.
When you say see, what do you mean exactly?
In other words, detect it.
And how do they detect this ring or cone?
Well, they have detectors that can detect light. Okay.
They're detectors that detect.
Yes,
Light.
that's what detectors do. Yeah.
Light. So like photons, like
Yes.
actual.
Yes, photons. Yes.
Okay. Do they? Is there do you have an image of any of these cones?
They do. So I'll share that with you later on. Okay. So can you move to the next slide, please?
Certainly.
Yes, please, Greg. So this is the one, the one in Italy. So if you move to the next slide, you can see this is the one that's from CERN in Switzerland, in Geneva, and that's going through the ground. It's travelled through the Earth and to the underground detector. 3.3 degrees actually through the ground, and you can see all these cities that it goes past. So it obviously wouldn't be going. It wouldn't be going like that if it was going through flat Earth, would it? Okay. And then other ones.
I totally concede that this cartoon definitely would debunk the cartoon flat Earth. Yes.
Well, it's like anything. This is just a diagram that I've put together. Okay, so if you want to read more about this and read the scientific papers that describe this experiment, you're welcome to do that. Now, like I said, I'm not here to convince you. Okay, I'm here to show people, and including you, how why it is that I believe that the Earth is a globe. Right.
This is good for everyone.
Okay.
Yep.
So you can accept the information, you can accept the evidence or not. It's up to you. You can look it up and then say, "Oh, they're all lying to me. It's not true. Never happened."
Is that how the peer review process works? You just accept what your colleagues say?
No, that's not how it works. So the peer review works like this. Somebody submits a scientific paper, and then lots and lots of people test what that person's done, do the same experiment that person has done in their paper to see if it's true, to see what they say is right, and not only that, criticize them if some assumptions are made that shouldn't be made.
Peer review is pretty brutal.
So the people who are doing peer review, their job isn't to make this thing pass. Their job is to make this thing fail. It's their mission in life to make that paper fail. They're not trying to pass it.
So I'm sharing a picture of like the only picture I could find of like this Cherenkov effect.
Where are you sharing it?
I'm just sharing my screen.
Right, okay. Let me just switch over to that for everyone. Hey, Riker, shh. Silly dog.
Okay, so just to continue, you understand what my argument is, and you even said that would be cool if it was true. And if that could be shown to you, that you wouldn't be a flat earther anymore, would you? Because obviously...
What are you going back to the pylon thing? So real quick, when I'm streaming is
No. I'm talking about the neutrinos.
Yes, I'm showing the neutrinos right now. So what this is claiming is that the blue glow in that water.
You think the neutrinos, they're lying about neutrinos?
No, it's not lies so much as just believing things they can't see, and they're just assuming.
You think they made up neutrinos just the full flat earthers? That's what you think?
No, no. See, like this is so when.
You think they gave the Nobel Prize to Cohen and Raines because so that we can trick flat earthers?
Am I echoing or someone else?
No one was echoing.
Okay, I heard echo. So the image I'm showing is the blue glow.
Phil hasn't
water,
been muted, has he? He cut off there just to check.
Let me know when I can speak.
Yeah, I'm just double checking that Phil hasn't been muted because he seems to have gone quiet.
No, he didn't get muted.
Oh.
Right, there we go. Okay, sorry. Yeah, please, sorry, Q up. Yeah, we can hear you, Phil. But sorry, let's just give Q up a second to finish what he was saying. I'm gonna obviously I want to make sure that everyone has equal time. So, what were you saying there, Q up?
So the image I'm showing, they're claiming the blue glow is caused by millions of overlapping cones producing a glow. So this is not. So there's no images of like one single cone I can find. This is supposedly like the best example of this Cherenkov radiation.
Well, of course, you
effect,
wouldn't be able to have one cone because there's so many neutrinos going through all of the time.
So his claim is that you could see like the angle change, just like a
the detectors are able to pick up the individual cones because that's their job. That's what they're designed to measure. Now, when Phil says you can see them, it doesn't necessarily mean with your eyes. It means the detectors have the ability to detect the direction that all these cones are going in. Now, to your eyes, it's going to just look like a bit of a blue glow because there is so many of them all of the time.
Yes. Okay, so my question to you is that you can accept this evidence or not accept this or not as you please. But if you don't, then are you asserting that they gave the Nobel Prize to those two scientists for nothing? They were lying.
Very sad. Very sad.
They just wanted.
Yes, it's like propaganda. The prize as a way to boost up someone's.
Let Phil finish his point before you answer, please, Kyop.
They did all of that. Gave out the Nobel Prize for Physics. They peer-reviewed all of this. Thousands of scientists all over the world would have done this paper. Would have looked at their paper, and they did all of that just to lie to flat earthers.
Well, the people involved aren't doing that all to lie. They actually think they're getting like a prize for something that they did that's good, but it really is just they just basically added into the amount of band-aids for the globe model, like this cone claim.
You think they didn't see you think the detectors didn't detect the neutrinos?
Also, who knows what the detectors are doing, but no one's actually seeing these cones to verify if these angles, like you claim, are actually how these neutrinos are coming in.
You're welcome to read the papers, right, and see how it's done.
The papers isn't what the instruments are reading.
They'll tell you blow by blow how those instruments do it.
I know, I'm sure it will. That's not for flat earthers. We like actually seeing things in reality, like with our eyes, so we can see if it's real.
I get that. You see, the thing about being a flat earther is there's so much you have to deny, so much reality.
Yeah, I don't see. I actually granted that these neutrinos are even real. I'm skeptical that they even exist. So I'm granting that. So I'm not denying any of this. I'm just asking you for some evidence that you guys have built all these worldviews upon. Like it's a lot of claims.
My job is to tell you what.
There's just a glowing blue in that water, and there's claims of millions of neutrinos that are coming in at different directions from the sun. If these things travel forever and there's like infinite suns, how would you know how would there be like a direction of how could there be one specific equatorial mount style direction from just one sun if these things travel forever?
Okay, so basically that's a really good question. I asked that question myself many times. Okay, and that is and the reason is the inverse square law means that other suns, which are trillions of miles away, those neutrinos are spread very, very far by the time they get to us. Whereas the sun is pretty close. The sun's only 150 million kilometers away. It's very, very close. And so all of the neutrinos that we get, practically all the neutrinos that we get, can only come from the sun. That's the local sun. That's why we know. But it's a good question.
So ChatGPT is saying that neutrinos from other stars do reach the Earth all the time. Our sun emits a vast amount. Every other star in the galaxy does the same.
Hey, queue up. Can we not just go to ChatGPT for information, because ChatGPT can't even spell its own name? ChatGPT is wrong so much for everything.
Let me handle this.
I know, but I'm saying it's ChatGPT just so we know that. But
Sure.
distance doesn't stop them. It says distance doesn't stop them. Most travel in straight lines. I mean,
If you're going to use ChatGPT as a source, just ask it what shape the Earth is, and then we can finish there.
Craig, let me finish this.
Yeah. Sorry, on you go, Phil. Yeah.
Okay. Take Americans call this a flashlight. We call it a torch. If you have one of those, right, and you shine it, the things that are pretty close to you, you can see them. They're pretty bright. But when you shine the torch a long, long way away, people in the far distance can still see the light from your torch. Okay. However, you can't. The light that's going there is spread. The further away you are, the more it's spread. Now think about this. Those suns, trillions of miles away. Okay, that's how far away those stars are. So yes, of course, neutrinos from them will get to the Earth, but that doesn't compare with the brightness of those neutrinos that you're going to get just from such a close sun. Because our sun is really, really close compared to those ones. So naturally, the neutrinos that we can follow, it's like following this bright area compared to all of the really, really, really dim area that might be coming from that's coming from other stars. But this really, really bright one, that's only coming from our star, from the sun, which is really close.
You say very bright, but again, we don't have an image of this brightness, so.
Well, you can accept the evidence or not, like I said. Okay, I'm not trying to convince you. Okay, all right. So basically, just to summarize the reason that the neutrinos will travel in a straight line. They come from our sun. They're created by the nuclear reaction that's happening on the sun. And we can create these things as well. Okay, they create them at Fermilab and at CERN using particle accelerators, and basically, just like the equatorial mount, you can actually see where the sun is, where its location is, depending on so the detector will detect where the sun is on Earth, even when the sun is on the other side of the Earth. Okay, so that has to be irrefutable evidence that Earth is a globe.
If you could show that, if you could demonstrate it, maybe.
Yeah, I'm glad. So far, I've explained to you about the equator, about the GPS. You accept that if that's true, then Earth is a globe. You accept that neutrinos, if that's true, Earth is a globe. So we're getting somewhere. There's all of these things. We accept that the bridge, the pylons, if that's true, Earth is a globe. So far so good. All you need to do is to.
You want me to correct the straw man, or are you going to continue? You're going to burn the straw man that you created?
Sorry, go ahead.
Yeah, I said if the pylons, if level pylons were
Plum, you mean
deviating
plum.
from each other, I said that would be good, good evidence. I wouldn't be convinced it was a globe, but there might be proof of non-parallel plumb lines. But I didn't say that about anything about GPS or this neutrino thing. I just said it would be good evidence if you could demonstrate it, which you can't. You just gave us a cartoon slideshow, and I looked up a picture of glowing water. And the beginning of your presentation, the beginning of your presentations was that these neutrinos aren't affected by anything. They can basically travel through everything and barely even like interact with physical matter. And yet now, if they have to travel too far, they die off because. You claim you can.
No one said they die off.
Yeah,
I didn't say they die off. Yeah, the inverse square of doesn't mean they die off.
Yeah, never reduces to 0.
Okay, they don't die off, right? It's just spread a lot further.
Okay, but there's more stars that aren't the sun than if the sun's like neutrinos were stronger or whatever, even though you said that they don't get weakened by hitting anything physical, there would be way more suns that are emitting neutrinos from different directions. It would be incomprehensible to try to figure it out.
Yeah, remember what I said, that we know that it's our sun because it's very, very concentrated. Because our sun is very, very close compared to the others, all right? Okay, so you can accept this evidence or not. That's up to you. I've shown you what it is, and I've shown you why those three things at least, why Earth is a globe. And of course, there's other things. Like, for instance, we have satellites that are going around the Earth. How do you think that happens? I have
another question about the neutrinos, if we could. So what about the sun makes neutrinos?
They're caused by the nuclear fission that's happening within the sun. You can, if you want to get some details, you can look it up. Okay?
So I'll answer that quickly. Basically, when there's nuclear fission, you're squishing two atoms together, right? But it makes a new atom, but there's stuff left over. And some of the stuff that's left over is emitted in the form of neutrinos, some in X-rays, some in other versions of radiation. One of the things that is left over from these two atoms squishing together are neutrinos. That's why they appear in nuclear reactors. That's why they appear in the sun. That's why they appear in the Large Hadron Collider, because when you're smashing two atoms together to make another atom, there's bits that have to be emitted, left over, because the mass of the atom is changing and there's nuclear reactions going on.
So I have another interesting thing that ChatGPT told me.
Dude, stop going to ChatGPT, please. It is so dumb.
Well, it's just a cursory thing, and then anyone that's interested in this topic can go deeper and see if whoever has more evidence for their claim. I mean, I'm just looking up what ChatGPT really quick. So the Earth's core does act like a nuclear reactor, and it creates neutrinos. From radioactive decay. So that would also add another, direction of neutrinos coming into these reactors.
Yeah, of course, we can tell where they're coming from.
Can you just focus on what I said? We can watch, we can see that this moves and points in the direction wherever the sun happens to be. It's not by coincidence, okay? Irrespective of background noise, the main cluster of these neutrinos follow the sun.
Okay, yeah, I understand the story, and I don't believe the story just because you say it and just because they told you.
Don't. Of course, because if you did believe the story, you couldn't possibly be a flat earther.
How could you believe the story and not believe the story at the same time? That doesn't make sense.
That's not what he said.
If you did believe this story, then you couldn't be a flat earther. Okay,
if you believe the story, you dig over. You believe stories, yeah.
No evidence.
Okay, now,
we believe evidence.
Next thing.
But before you go to the next thing, Phil, I just want to clarify one point that QOP has said. So, QOP, if you could be presented with proof that plumb lines diverge, you'd stop being a flat earther, right?
Are we talking about reciprocal zenith angles?
Yeah, and plumb lines. If I could prove to you that plumb lines diverge, would you stop being a flat earther because you've said that?
If
So if I could present to you measurements that are testable, repeatable, that you can do yourself, that are done by professionals, if I could present those to you, would you stop being a flat earther because you did say that?
You can't prove to me your interpretation of reciprocal zenith angles if I debate them all the time. Like, that doesn't make sense.
No, again, I'm asking you a very simple question. I'd like a yes or a no. If I could prove to you that plumb lines diverge, the higher up they go, would you stop being a flat earther?
If you could prove it, but you can't if you're dealing
Well,
with...
don't worry about the rest, just a yes or a no. If I could prove it, would you stop being a flat earther?
That's my question.
Yeah, if you could prove it, I guess, to me. Yeah, sure.
Right, okay, brilliant.
That's
I can
good.
stop you being a flat
That's
earther, no problem.
All right.
No, if you're
Okay. All right.
talking about
Okay.
spherical excess or reciprocal zenith angles, like, you can't prove that that's actually what's occurring.
Well, I can. That's very easy. And okay, now I know your standard of evidence. I can make you stop being a flat earther or show that you're a liar. It's one of the two.
Can we move on?
Yep.
Can we move on a little bit now? So all right. So the other reason that I'm pretty convinced that the Earth is a globe is it, for instance, is the star trails. See, the star trails. Everybody talks about the star trails going in one direction, and then look over there, they go in another direction. There's a much more fundamental problem than that. A much more fundamental problem than that, and that is, you first of all, let me just steel man you. You think all the stars go around the Polaris, don't you? Is that right?
No, and I'm actually going to do a video on this, so I promise you're not teaching me anything new.
Well, you don't know because
Okay,
he hasn't
so-
got to his
so-
point yet. So please stop. Don't be that
Well,
arrogant.
That's
yeah.
good. Hang on, Craig. So we could get on the same page with this then. All right. So is the North Pole in the center or not of flat Earth?
Yes, but that has nothing to do with what's going on in the sky.
All right. So is Polaris, the GP of Polaris, practically above the North Pole?
Most likely.
Okay. All right. Good. All right. Okay. And the stars are all going around, aren't they? So they're all going around the North Pole.
They don't
Or not?
travel in straight lines like in the globe model, within my model.
You have a
But
model.
in your model, do they go around a circle? That's what I'm talking about. Like the sun. The sun
maybe
goes around
so.
in a circle, doesn't it, on your model?
So, what you see optically and what is actually physically happening with the energy sources are two different things.
How are they two different things? How did you determine that they two
We
different
don't live
things?
in a video game world where you see like God mode and you can just like see everything.
How
in-
did
in
you
straight
determine
lines.
that? How did you work that out?
I see perspective, converging in the distance just in a local area, so I have no reason to not think that.
Not how that works.
That sounded like gobbledygook, but anyway. All right, let's just deal with the sun then. All
A
right.
word salad.
Okay. So the sun goes around in a circle, does it? Because it goes from country to country, doesn't it?
So, physically, so first of all, I don't believe the sun that you see is actually the point of where that energy source is originating from. It's when it hits you the most is when the sun optically that you see is at your zenith. But that doesn't mean that is the thing that's causing that. So
But when you see this, when you look in the sky and you see the sun, is it there or not?
I mean, I just answered that question.
No. Well, do you see something there?
Yeah, you
Doesn't
see
matter where you
rainbows.
think that it-
You see rainbows, right? Are they there? Are there rainbows there?
Yeah, of course.
Oh, they're there.
Right. Yeah. The light's coming through the water is actually there, causing the diffraction. So naturally they're there. Right. So
the rainbow you see is not
right,
in the
forget
location.
the rainbow. I don't want to discuss rainbow. I want to discuss the sun. The sun. Do you agree that we observe the sun going around the Tropic of Cancer? Do you agree with that bit? It doesn't matter where the sun comes from, or the energy comes from, or all the woo that you can think of. I'm asking you, do you know that we observe the sun going around the top of the Cancer?
The zenith of the sun, whatever the sun is, does follow the two tropics.
And the equator, of course, yeah? So it goes between both of them. Right. So they go around. So if you're looking at something that's in the distance, that's going around your head. Let's say, for instance, you had, let's say it was a helicopter going around, and it was going around your house, let's say, okay? As the helicopter gets further and further away, doing the circle around your house, it gets lower and lower it gets closer and closer to the horizon, doesn't it? The further away it goes. So you still see going around your house. But you notice something about it. It's going horizontally in your field of view. Now, I want to know, how come the stars that are supposed to be going horizontally in your field of view are not doing that? They're making circles straight ahead of you. How's that happen? Why aren't they going horizontally?
Yeah, I know you don't like. So I already addressed this, right? So I don't believe that the apparent stars you're seeing, the apparent sun, is the actual location of that energy source, and I don't believe light travels straight like you guys do.
It doesn't matter. It doesn't matter about the parent. It just matters when something's going around your head, wherever their energy comes from, wherever their parent energy comes from, whatever woo you can think of that makes that energy, you see the thing, you actually see it with your own eyes.
I don't know if you know this, but even in your model, there's an apparent sun, just like during the Saturnian eclipse, during the equinox, when the sun is above the horizons for more than 12 hours. So I don't know I don't know why you don't know about refraction.
Please don't make assumptions that the professor doesn't understand refraction. You are just making random points there.
He called a apparent position woo-woo.
No, he called your description of things woo-woo. You are making assumptions about what he is saying. Let's not do that, because this has been quite respectful up to this point, and I try and like to keep it that way.
Okay, so you see the sun, right? Why is the sun not going horizontally across your grid? Why does it go, if you're at the equator, the sun actually goes right over your head, especially in March and September. The sun goes right over your head, right angles to the horizon. Why isn't it going around in a circle?
So as far as like I mean, there's so many things I feel like you don't understand about optics. But so
again, let's please not make assumptions that the professor doesn't understand things.
No,
that's
hang
a
on.
bit rude.
It's all right, Craig. I want to know, what about optics would make something that's supposed to be going around my head in a circle? In other words, I see it in the distance I should see it going horizontally in the distance. That's how I should see it. And then when I'm at the equator, it doesn't do anything like that. It goes over my head, right angles to the horizon. Comes up from the east at right angles to the horizon, goes down to the west, right angles to the horizon. Can you please tell me why it's not going around in a circle if that's what it does?
Right, so you're assuming that on a flat Earth you would never see the sun setting and you'd be able to see it do that entire circle.
Mm-hmm.
I agree that would be true, yes. Yeah, that's where I'd say you wouldn't see the sunset. Yeah, exactly. The sun couldn't set.
That's a problem. How can we explain to you like how our model works if you can't understand that like there's a standard refraction that you guys even account for that causes light to bend downwards towards the higher pressure, and there's also perspective that causes what you see in the distance to get lower and lower. So there's no reason for you to see the sun always in the sky.
I know you love those words like perspective, okay, but that doesn't explain what I'm trying to put to you. I need you to focus on what I'm saying. Something that's going around your head can't go below the ground.
Let me try and break through this miscommunication here, Phil. I think what you're missing here is that QOP doesn't believe the light that we see actually comes from the sun. The sun is actually in the position that it is. Obviously, for us, if the sun is a physical object orbiting around the flat Earth, then that is what we would assume would happen. But what QOP is saying, and please correct me if I'm wrong here, QOP, I'm just trying to get rid of the disconnect. What QOP is saying is that the sun isn't actually the source of the light or the energy that we see. Therefore, there's no reason in his version of the flat Earth model that it would circle around above, because he has some other version of optics / perspective / what the sun is that explains what it does. Is that correct?
Yeah, and I don't have it all like fully figured out, but for the most part, everyone has a problem with for the most part, everyone has a strange explanation to give for the equinox sun. So the sun is visible for more than 12 hours during the equinox in many areas. So that is geometrically impossible in your model and in concave and flat Earth. It doesn't make any sense.
It does. I'm afraid you're wrong.
How could so you know so when you're on the globe, right? Your field of view, if you extend it past through the horizon into space, where would that line get to? As far as like with the sun's orbit around the Earth, like would it be?
We don't think the sun orbits the Earth.
Or would it be that?
Sun doesn't orbit the Earth. The
well,
Earth.
So visually, okay, yeah, sorry. Visually, like the sun goes.
Okay,
I guess you're right.
What we see it, yeah.
So,
okay.
As far as like where the sun is visible from the Earth, when it's like along the equator, right? So that's like that's intersecting like if you draw a straight line through the diameter of the globe into space and where the sun gets to at that center point, that's where it should be 12 hours later after it's the other side of that circle it did. There's no way for you to be on top of a globe and see the sun for 12 hours of your vantage point on top of the globe. Do you understand?
The sun, look, the sun takes 12 hours from if you're on in March, around that. In March, the sun will come from the east, 90 degrees from the east coast, and it'll take all day, all 12 hours before it gets to the west coast. I don't know what your problem is with that. How would that happen on flat Earth? I'd like to know. Getting over your head. Why isn't it going around in a circle? Why is it going over your head? That's the bit I'm stuck with.
Yeah, so I don't claim like the sun you see is like an actual like object that's actually like needs to be like where you guys think geometrically based on like where it is other places. Like, so everyone has like an apparent sun in the globe. Like I want to show you the thing I was just talking about. I actually have a little diagram I made for my next video because I'm actually going to do a video on this. Let me.
You got a cartoon for us? Cool. Yeah, please share your screen. I don't see your stream. Oh wait, there we go.
Okay, so yeah, wait till people join. So Professor Phil, can you look at my my stream? Click my QOP name.
You can see a couch there. Oh, that's great. Okay.
Different stream.
Let me have a look.
If you click the thing that says live now, I've stopped my sharing, so the only live thing should be QOP stream.
Okay, I can see it. All right, it's coming up. Yes. All right. Good. That's a globe. Yeah.
Okay, so this is I made this diagram for the two star rotations. So, but it's the same problem with the more than 12 hours of sun visible on the globe during the equinox. But you can just we'll just switch it
There's no
to
problem
this
with that.
with being able to see two star rotations at the same time, which is it's been photographed as both star rotations from specific point on the Earth. I'm not sure where, but
At the equator.
there's a
Yeah,
couple
if you're at the equator and you use a wide-angle lens, or you do a panoramic shot, you can look both left and right, or north and south, and you can get the star trails going. But that's obviously only visible from the equator.
Yeah, perfect. So like this line on the left I have that's like kind of like parallel to the line that's basically gonna intersect with Polaris. That's from the equator. That's where if you were like your horizon, obviously when you're on land, is like eye level. It's like ground level. It's 0 degrees to the horizon from where you're standing. So that line that you extend out is never going to reach the star rotation of the north, and it's never going to reach the star rotation of the south. It's going to you're going to see basically next to those two areas, but you're never going to see both at the same time.
Why do you think that?
It's just geometrically impossible. Like
Maybe geometry means
Let me
something
give
different to
you
you.
an analogy. Hang on, Craig. Let me finish this.
Sorry, my brain freaked out there.
Let me give you an analogy, okay? Let's say you have a tennis ball, and the tennis ball is, and you've got a telescope so you can see it, okay? And you've got a telescope that's say 1 kilometer away. That's going to be pretty small. Wouldn't you think that the rays coming from that tennis ball would be pretty much parallel, wouldn't they, given its distance away? Would you agree with that?
are you talking about?
Do you understand that those stars are very, very far away?
Yeah, I know your light travels straight in your model. I'm not. That's why I'm baking on that with this.
Why can't I see yours? Have you?
He's turned it off.
You're not running
Phil.
it anymore.
Yeah, he
I'm gonna
stopped
pull
that.
up a different. I was gonna pull up some images of star trails.
All right. Now, can you tell me what you did there? And then now that you know that the how this works, and you know that at the equator, yeah, like that. Can you make what you're looking at there? Can you make that fit on flat Earth?
Well, there's no geometric connection between the sky and the ground on flat Earth. This is just an optical. Like, we don't know what any of these lights are, and they don't have any like strict way of behaving as far as how the light gets to us.
They do have a strict way of behaving, thankfully. Otherwise, we wouldn't be able to use them for navigation.
Well, there's a consistency of like like where what's at your zenith and what direction things are, but as far as like it doesn't have to, like, just because you use it for cell nav doesn't mean like it has to be the angle to the star has to be the actual position of the star. It's just where you see things.
Can you explain what you're looking at, how that would work on flat Earth?
I was trying to get you to explain how this works on the globe, because those two
No.
rotations.
You want to be a flat earther, so all these things have to fit flat Earth.
No, the ground and the sky and the stars on flat Earth have no connection.
What?
So, would you agree? I don't know. So the navigators get it wrong.
So the main thing is that in your model you have a vacuum of space and light travels basically infinitely, even though you said the inverse square law applies to neutrinos, but it doesn't apply to stars that are infinitely far away. Blah blah blah. So in our
To be
model,
fair,
like
let me just cut in there. That is a bit of a straw man.
It's not a vacuum. It's not a vacuum around flat Earth in our model. I think
Who
there's
said that the inverse square law doesn't apply to stars?
Yeah, let me just clear up the straw man you just did there, Q-Up. No one's saying that it doesn't apply to stars, and no one's saying the inverse square law means that light stops. It means that its intensity reduces over distance, but because it's an inverse square function, it can never reduce to zero, which means it will never be nothing.
Well, it seems like pretty much. Okay, so in the flat Earth model, or at least mine, there's mediums. These are extremely energized, like superfluid mediums. They're ionosphere, like times like times like a million, like the higher and higher you go. So all these anomalies you guys see with like the Einstein like warping around whatever you guys claim, all these warping effects is explained on like a closer scale, and because of actual mediums that are above us.
So who told you about what's your evidence about this superfluid mediums?
Well, that's like, we could get into that, but I'm just saying, like, so when you have like
I'd love to get into it.
I'm just saying, so like when you have an actual medium causing like different levels of refraction, you don't have to basically tie like geometrically like where you can see a star from the Earth depending on its shape, because you could be seeing around corners in a sense because of the medium being weird.
Okay, so this superfluid medium, I'm really interested in that. I'm a physicist. I'd like to really know about that. Can you help me with that, please? The evidence for that and all that?
I believe everything gets more and more charged as you go up, and that's why satellites can float in the air.
The superfluid I'm talking about.
Yeah, it's just a... Sorry, what about it?
You said superfluid. Medium. I'd like to know what.
Yeah, it's like highly ionized. It's like a highly ion. Well, it's just it's like theoretical. Like just like you guys make up Spacetime to explain things. I'm admitting I don't know what's up there.
There is no evidence. So there's no evidence for that. Okay, sure. So you think that what we're looking at has got something to do with superfluid medium, and that's why it looks like it ought to be on a globe, right? Because that what you're looking there. You admit that that's exactly what you'd see on the globe.
I didn't say any of that. I didn't say any of that. So one thing that shouldn't look like what you're seeing on a globe is that diverging and converging of star trails around the celestial equator there. Which so the two star rotations make sense on a globe. I don't think you should see them both at the same time anywhere, but we'll try to figure that out for my next video. But the converging and diverging star trails you guys claim, or the mainstream claims, is because of the axis of rotation causes like this warping effect of the but that doesn't make sense geometrically in your model. There's no in my model, like there could be something there that has like an energetic effect that refracts more or less and causes that at your zenith on the celestial equator to be the stars like closer to the equator, but you guys don't have that in your model. So
would you agree that what you're looking at there, what you put up there on the screen, would work perfectly on a globe?
Did you hear anything I just said?
Yes, I did.
Okay,
you think there's some superfluid,
that was like a minute ago or 2 minutes ago.
I want to know why you think why. I want to know what you're looking at works perfectly on a globe. And yet you don't accept that.
Okay.
I heard what you're saying. You're totally wrong about the other thing.
The celestial equator is a straight line. The stars around it on both sides converge and diverge as they get closer to your zenith at the celestial equator.
Will what you're looking at work on a globe?
That won't. What I just said won't.
What you're looking at will work on a globe perfectly.
Okay. I don't know if you're listening.
And so will the sun. And so will the sun going directly 90 degrees to the horizon and come up on the east 90 degrees to the horizon and go down in the west 90 degrees to the horizon. That also would work on a globe. You have yet to tell me, other than we don't know what the sun's doing. That's why that explains it. And yet it works perfectly on a globe.
Except for all the things that I pointed out, you haven't addressed any of the things I pointed out. Any of them.
I have.
Right. So specifically, let me. This seems to be going in circles right now. So specifically, just give him one thing that he hasn't addressed, and then we'll see if Phil can answer that for you.
Well, just now I repeated the converging and diverging of star trails around the celestial equator.
Right. So what you're saying is, I just wanted to clarify so we can get a straight answer. You're saying the picture that you are showing on the screen right now does not work on the globe. Is that correct?
Oh yeah, there's other reasons, but that's the thing I keep pointing out.
Okay, I mean, you're completely wrong. That's exactly what we expect on with a 360 picture on the globe. But Phil, could you just respond to the fact that he is saying that the picture on screen does not work on the globe and how it does work on the globe?
Let me start by saying, if this wasn't working on the globe, then this would be working on flat Earth, right? Obviously.
Was that a question?
Yeah.
Yeah.
That was a question.
Yeah, there is a question in there. Yes.
I thought you were asking yourself. I don't know. I'm confused. Like, you hear the words that I'm saying? No, I don't know.
He asked you a question.
Tell me why is?
I don't think he does. He know what celestial?
I'm saying this works. What you're looking at works perfectly on a globe. I'd like to know why you think it doesn't.
Celestial equator, converging and diverging stars around it at your zenith.
What about them, and why doesn't it work on a globe?
They're not in reality. In your globe model, they're not actually converging and diverging around the celestial equator zenith.
They would look like they are from the equator with a 360 picture.
Why would they look like that?
Because you're at the equator, which is spinning, and that's exactly what you would expect to see if you have this isn't just like one shot. This is a 360 panorama picture that's like been stitched together. The edges don't even match together. With a 360 camera at the equator, this is exactly what you would expect to see on the globe.
So because of the rotation?
Yes.
Can you guys show anything else rotating, like a camera and rotating and causing that effect?
We don't have other globes.
Okay.
Listen,
this is one of those things that can't be replicated.
What would you, if you let's just say the Earth is a globe, right? And what would you expect the stars to look like? What direction would you expect them to be going in if the Earth was a globe and you're at the equator? What would you expect to see?
Like I said, I don't think you would see both poles pretty much at the same time there. And I don't think you would see the convergence.
No, I'm not saying. If you had this image, like Craig said, comes from a 360 camera. I'm talking about you standing at the equator, looking up at the sky, watching the stars go. You'll see the stars going down below the horizon. Do you agree with that bit? Agree that if the Earth was a globe, that's what you would see.
You see that no matter what, because you don't see forever.
Oh God!
Did you hear what I said?
Yeah, whether it's a globe or flat or concave, you wouldn't see forever.
Why not?
No, I'm not talking about that. I'm planning to get to that. I'm planning to get to that in a bit, because I want you to answer. I want you to tell me why it gets dark at night. But we'll get to that. Okay. All right. What I want. I'm asking you a simple question. That if you're at the equator and the Earth is a globe, would you expect to see both the sun and the stars just go directly ahead of you, 90 degrees to the horizon, and then disappear under the ground? Would you expect to see that if it was a globe?
You would expect to see it no matter what. If something that far from you.
No, just say yes. If it's just a yes or no question.
No matter what, on a globe, on a flat Earth, anywhere, yeah.
Okay, so all right. So now you agree that that's what would happen if it's, say, in other words, what we see matches the globe, right? We just said that.
No, so like there would, if the globe was real, you would have two things causing everything to basically wrap around you. You would have like your perspective and the atmospheric lens around you, and also this globe that actually has balls going around you. So,
and we just focus on what we're looking at the equator You agree that if it was a globe, we would see the stars go directly down, right angles to the horizon. We would see that if it was a globe. That's what we'd expect to see. You agree with that bit?
Oh, you expected to see it in both models.
Okay, so now let's look at the other. Now let's consider the other model. According to you, all the stars are going around in a circle.
Dude, you're okay. I think we're going around in circles, and you're not listening to what I'm saying.
He is, but you don't seem to be responding to his questions.
He's like talking to himself. I think it's like weird.
Right, he's really not. He is trying to understand your point of view by asking you questions that are simply yes or no questions, but you don't seem to want to give yes or no answers. You just keep saying different things to his question.
Well, we circled around back to the beginning where he still thinks you were treating flat Earth like this Euclidean flat Earth where you can see forever and draw straight lines to the sun as if there's no atmosphere, no pressure gradient, no perspective. Like we just live in a video game. Like, yes, in a video game flat Earth, like the sun wouldn't set. Are you happy?
Right. Okay, so let me try and clarify. Phil, he doesn't think that the flat Earth model is what we are used to talking to flat Earthers with. He doesn't think the flat Earth is just a plane with a sun and a moon orbiting around above it that would, be visible in the sky at all times. He has a completely different model which defies all known physics, all known logic, and all known reason, but it makes sense to him.
Yeah, that's why I call it woo. Okay?
Yeah, exactly. Yes. We all understand that, but it's this conversation isn't going to progress because he disagrees with every precondition that we would understand what the flat Earth would be. I think we would need to see his model in its entirety for this line of questioning to make sense. So why don't we change tracks? And for we've been going for nearly 2 hours already. So maybe for the next 10 minutes, why don't we let QOP tell us what his absolute 100% best proof that the Earth is flat is, and just try and stick to one thing, QOP. Right? Phil's given a lot of his evidence, which you've just denied, which is great. And if you want to research it some more, then I'd encourage you to do that. But why don't you take this time now to just choose what you think is your one greatest piece of flat Earth evidence to give to Phil, so that we could maybe have a 15-minute conversation about that before we wrap up for the night. Sound good?
Yeah, that's a hard one. I mean, I haven't actually measured the ground, so pretty much everything. Reason I believe the Earth's flat is based on just debunking different parts of the globe and eventually.
Well, okay. Like I said, just choose one thing that you think is your best proof of the flat Earth. Don't talk about some of the it is try and make it something that's exclusive to the flat Earth that would show this is 100% proving that the Earth is flat in your paradigm. All right, don't try and debunk the globe as your evidence. You try and give something that would be that wouldn't work on both the globe or flat Earth. Just try and give one thing for you that is specifically the best bit of evidence that people can look at and scrutinize that shows that the Earth is flat. Okay, sound good? It doesn't have to be measurements or anything. I didn't ask for measurements. I just want what you consider your highest bit of proof that the Earth is in fact flat.
Well, I mean, the thing is, I wouldn't just. So I think on a globe and flat Earth, how far you see is just depending on optics. So to just pick, for the most part, most of these things we're arguing about optics. Why? It's distracting when you bang your head.
Sorry, I use my facepalm protection.
I'm not aware of any actual physical measurement of sea level that I would trust. So it's not like I've measured myself sea level to be level. So I just assume it is because it'd be ridiculous to believe the the opposite based on the evidence you guys give. So it's pretty much, for me, it's just the evidence you guys give is not evidence. It's circular reasoning.
So you don't
And
understand the
therefore,
evidence. Okay, but I want your evidence that the Earth is flat. I don't want you to try and say what you don't understand about the globe. I would like you to present Phil.
Pretend you never heard of the globe.
Yeah.
Now, pretend you've never heard of the globe. You've never heard of it. You don't know anything about it. All
Right.
you got is you got to tell a bunch of kids over there why you think the Earth is flat. Go ahead.
well, you don't feel it moving, and
Oh,
there's
good
no
Lord.
reason to everyone intuitively understands perspective and how you're going to have
You
a horizon where you stop seeing.
Are you going to tell the kids perspective? Or are you going to give them some actual evidence?
Well, so the alternative is that the Earth's a globe, and then usually just explain to the
forget the
kids
globe.
why, how.
Get the globe. Nobody's
Well, the
heard
only-
of the globe.
The only reason you would think it was a globe is because you misunderstood perspective and thought things, wrapping around your field of view is somehow proof of the globe. And
Kyoba, I'm going to try once more to lay the
not.
premise of what's happening here. I don't want you to say what you don't believe about the globe. I want you to give what you think is the best evidence that the Earth is flat. Ignore the globe. Try and present something that is exclusive that would show that the Earth is flat.
Yeah, but the only evidence that the Earth was flat would be to actually have a measurement of it, and we're not talking about measurements. We're talking about optical, like.
But we have got measurements that the Earth is a globe, though.
Lots of them.
Well, you guys claim that.
No, well, it's not just claim.
It's proven.
I've got it.
Beyond a shadow of a doubt.
So I want to show him. I want to show him.
So you said one of the things I said would actually. So the only thing that I would agree would be a measurement was that thing you said about the pylons diverging.
Like the Venice Aeronauers Bridge with the pylons being 5 and 3 inches. The Venice Aeronauer Bridge, the pylons are 3 and 5/8 inches further apart at the top than the bottom, and that's been measured countless times.
Okay, but do we know it's like that the plumb lines are also diverging? Or
Well, yeah,
do
they
we
have
just know
to-
that the pylons.
The pylons have to be plumb because they're suspension bridges. That's how they work. If they weren't plumb, then the bridge would kind of fall apart. Suspension bridges have to, their towers have to be 100% plumb. And the Venice Aeronauers Bridge, the top of the pylons are 3 and 5/8 inches further apart at the tops than the bottom. And we know they're exactly plumb because it's been measured many, many times.
Okay, did they videotape measuring that discrepancy?
You don't have to video something for it to be science. That's not how that works.
Okay, so
you
there's
can
plenty.
accept that. Not. It's up to you.
No, I don't. That's not an argument. Just you can accept that.
Well, we gave you the evidence. I gave you the evidence.
That's not. You guys just told me stories. That's not evidence. So you guys saying I have to bring evidence of a measurement, which I haven't done. Which
Well, you haven't
I
given
also
me
wouldn't.
any evidence of yours.
I wouldn't blindly trust flat earthers' measurements either. So you guys aren't presenting
Why are you
measurements.
trusting
You're just
Earth
telling me
is flat
stories.
already? But you are a flat earther, which means you're on the side of flat Earth, and yet you have no evidence for actually doing that. I've given you evidence for why I think I gave you honest evidence of why I think it is. But there's one I have to show you before I go.
Yeah, okay, well, let's do this. All right, Keop's just admitted he doesn't have any evidence that the Earth is flat, so that's fine. We understand that there is no evidence that anyone can ever present that the Earth is flat. But Phil, if you want to do one last bit of globe Earth evidence, and then we'll call it a night. It's coming up for close to 2 hours. So if you're okay, Keop, we'll let Phil present one more bit of evidence that the Earth is a globe. Then a brief discussion, and then we can do final thoughts and close up. Okay.
This is just one thing that I have personally had something to do with. So if you have a look on your list of pictures that I gave you, there's one there that's got a section of Earth, so it's sort of a greenish color.
The Chandrayaan-2
An
orbiter
actual
close
photo.
up.
That's the one. Yeah.
Yeah, okay, let me get that on the screen so everyone can see, and I will share it over here. Bear with me 1 second. Okay, yeah, that is up for everyone to see.
Can you see that?
Yeah. So we're looking at the Chandrayaan-2 mission. This appears to be above. Is that South America?
It's you're looking at no. You can see the Mexico. You're looking at the coast
Right.
of
Yeah.
Mexico.
Okay. Yeah.
there, and you can see the-
Right. Yeah. So we're looking just at Mexico. Why is
you can
the
see
image slightly green?
Baja
Phil?
California.
Yeah. Why is the image slightly green? Is that the imaging sensor? It was set for a particular wavelength.
Yeah.
Right. Okay. Okay. Right.
And,
So
because
what is
what that is-
yeah? So tell us what
Can I-
this
can
is
I
then,
just
Phil. Yeah.
explain? All right. So the Earth is extremely bright, as you know, with the sun shining on the Earth is very, very, very bright. So they've had to. That's why you can't see stars in this image here. That's because you've had to adjust the aperture so that you can actually see the thing. Otherwise, it would completely wash out the entire the sensor if you didn't do that. This particular I think the Earth is very, very bright. So, but what we can see now, we can actually see some of the Earth. Now, I don't know about you, but Earth's a globe.
Well, yeah, I would agree. What do you think you're looking at here, Q-Op?
Bro, really?
Yeah.
I mean, we've exposed like so many of these pictures being like stitched together, repeating clouds. Like, I mean, let's look at the blue marble.
Well, no, we're not talking about blue marble, which we know is a composite image. We're looking at this image that Phil is presenting from Chandrayaan-2.
This is my crowning glory. Okay.
This was the mission that Phil was actually involved in. So let's look at this image.
It'll be the coolest thing I've ever done.
You were in space?
No, this is from a camera on a rocket.
Were you in the rocket?
That's irrelevant, right?
Not.
You've immediately deflected to like the Blue Marble 2012, which everyone knows is a composite image.
When you watch a ball game on TV, are you at the stadium?
Yeah, so it could be done in a studio.
How could this have been done in the studio?
I said you're entitled to.
How could it not have? Like, why is that like so hard to consider?
Well, you would have to provide evidence of that. I mean, the Chandrayaan mission was tracked in space, and Professor Phil put it in space. So anyway, Phil, what's your point about this? Is it just the fact that you did this and you wanted to show it?
My point is that they're always saying, well, you didn't do this, you didn't do that, you weren't involved in that, I was involved in this. Okay, so I knew about this Li4 camera was tested on the ground. It was tested when it was attached to the craft. It was tested before the launch. It was tested after the launch. When the Earth came into view like this thing took a picture of it. In fact, I actually have one that's even a complete Earth, But of course, you know, you didn't want to show you that because you'd immediately say, "Oh, that looks like the blue marble." I say, "Yeah, doesn't it?" Of course, it does. But here's this one over here. I was actually at the Bangalore's thing when this picture was taken.
And
So
to be
that's
clear,
my
this is
personal-
this is the lander that did the hard landing on the moon, i.e., it crashed into it, right?
Yes, this is the one. Yeah, Chandrayaan-2 made it to the moon, but like you said, it lost the telemetry and basically crashed. Yeah.
So if I could steelman your position here,
By the
Q-Op,
way, the
and
bit-
please tell me if I'm wrong,
they
but
still
your
call it-
argument here, Q-Op, is it could be fake, therefore I don't need to comment on it. Is that right?
Yeah, that's what he's saying. That's flat Earth for you.
We've proven that these are fake. These pictures.
Well, when did you prove that
This
this
one's
picture was fake?
No, we've proven other pictures are fake. So
No, what
Why-
you've done
so there's
is
no-
you've looked at the 2012 Blue Marble, which is a composite image, and everyone knows it's a composite image, and gone, therefore every image ever is fake. This is not the 2012 Blue Marble, which was done using low Earth orbiting satellites with many pictures that had to be stitched together in Photoshop. No one's ever disputing that that's what that one particular image was, but this is not that. This is just one picture. This is not a composite. This is, there's no evidence that this is fake. So what is your evidence that this image is in fact fake. Without mentioning the blue marble from 2012, because this is not that. This is not NASA. This is nothing to do with NASA. This is the completely different organization, one that Phil was involved himself with a camera that they tested themselves. This is not a composite image. This is one photo. So what is your evidence that this is fake?
So how come it doesn't have that like line of the atmosphere like the Artemis mission's photo has like around?
What line of the
outside
atmosphere?
that?
What are you talking about?
Talking
The
about
Artemis-
the Terminator line.
Because it's not the whole
Maybe,
globe.
well, no, but in the new Artemis picture, you have like a line of the atmosphere, and then at the top you've got like the glow of like the the.
Because this is
whatever
a
it's
different
called.
camera
Okay,
with
he's
different
talking-
settings.
This is very far away. This is far away. That's why it's much further away than
There's-
you would
it's just
see.
too-
Remember I get what you're saying, and that's a good question. Okay, the reason that you can't see that blue, what you're talking about is that thin blue layer of atmosphere that you can normally see. Can't see it from here because it's too far away to see that. All right, because that thin blue layer is really, really thin. Okay, you've got no idea. You have compared to the Earth how thin our atmosphere is. It's very, very thin. It's like compared to something like a meter ball, it would be about the thickness of a piece of paper. That's how thin our atmosphere is.
Probably thinner,
Above
really.
that blue section.
But you realize in the
Into
Artemis
the-
picture, like I could repost what they showed for Artemis.
But this is not Artemis.
well,
Artemis
I mean-
pictures were
I mean, in the
backlit, right?
Artemis-
What you're doing,
in the Artemis
Q
one
up,
that's
you're
farther-
wait,
farther
Q up, hold
away.
on. You are moving away from this picture and you're talking about other pictures. This isn't Artemis. It's taken in a different
He's saying
position. It's
because-
using different light settings. It's a different camera and it's in a different position. So you would not expect it to look like the pictures from Artemis. So what evidence you have that this is fake other than going, well, it doesn't look like something else which was done in a different way?
He's saying it's very small, but the Artemis pictures from farther away, you see the whole globe and you see the line of the atmosphere.
Well, it was backlit. This isn't really backlit. You don't in many of the pictures from Artemis, you don't see that glow. You only see it in very specific circumstances. This is not one of those circumstances. This is not set up the same way. This is not Artemis. This is not NASA. Stop deflecting away from
Camera-
this and talking about other things.
Camera setting for this is is especially to avoid the brightness that this Earth is, that this particular thing would be, and therefore a lot of the background is all of the background is not visible because of that. Okay?
Yeah,
But
different camera settings.
That doesn't take away from the fact that this is not a flat Earth you're looking at. This is a real photo taken from an actual camera.
Do I have to answer that?
Yeah. You don't have to. I'm just pointing out to you why I think the Earth is a globe. That's what I'm here for. Okay.
Because
Well,
you
see,
sent some
you
into
think
space.
it is. You don't know it is, right? Because you've never seen it yourself.
Well, he knows it is. He's
I
measured
have.
it.
I've seen it. I have seen it myself. I've seen it through this camera. That's the point that I'm making. I have seen it myself. It wasn't something I saw on TV. It wasn't something I saw in a newspaper. It wasn't something I saw in a magazine. I was at the command center when this photo was taken.
I know it's very. I believe that you were. I believe that you, and I believe you believe
Right.
it, and I believe there's lots of people that work with these things that believe that they're.
You think
know.
you think they put a fake? Do you think they put a fake photo up there to fool all the people who are at the command center? Oh, let's just pretend. Let's just pretend. Let's get some artists to make up this thing here, and let's pretend to all the people over, all the scientists and engineers at this center over here, looking at that and saying, you know that thing over there? Let's fool these people and make something fake for them. Really?
Okay, well, so
And this
main,
is the same
main thing-
camera. We're pressing the same button to make this camera work as the same button that we used, the same piece of software that we used to make that camera work when it was on the ground. We're not making any difference. So all these people who had to fake it, they somehow had to interrupt the button that we had to press to make that work like it did on the ground. So we had to that. The software that did this They had to go ahead now. All the people who faked it. There's some unknown people who purposely know the truth and are faking it for the rest of us. So all of us over here, the engineers and scientists, are all being fooled by some unknown quantity.
Yes.
Seriously, you buy that?
You buy it.
Yeah, he was involved in it. Of course he does. He did. Again, right, let me clarify what he said. They tested the system on the ground. They pressed the button to take the picture with the camera when it was on the ground, and it then produced a picture that they saw. The same system, they pressed the same button on the same system when the satellite was in space looking at Earth. Exactly the same camera, same button, same bit of software, nothing changed in between, and it took a picture of the Earth. Your only answer here, Q-Op, is I don't believe it, and the reason for that is because it hurts your feelings.
Yes, that's exactly what I said, Steelman.
I mean, it's obvious. No, everyone here can see that you are coping really hard by deflecting away from this picture and just claiming, well, it's fake because reasons. You've got no reason to believe this is fake other than your feelings. This picture hurts your feelings.
Yes.
By the way, I need to clarify something. The software. The software actually takes the software presses the button, if you like. Okay.
Yeah.
All right. So I don't want to say that here's this button. I went and pressed this button over here. Okay. What we did with the software while it was on the ground, in other words, is the same thing that happened while the rocket was in space. Okay. So nothing changed. The software didn't change. It's the same stuff, the same camera.
But I guess that is where we could call the debate over, because Q-Op basically admitted defeat with that, which was fantastic. I'm just seeing if... Perfect soundboard there. Just seeing if there's any questions for Q-Op from my chat. Bill Tetley says, Q-Op, your incessant use of the word they to describe some shadowy group is proof that you never grow up past the angsty... anti-establishment high schooler phase. Grow up and do some actual research and learn. Not really a question, more a statement, I guess. Yeah, there doesn't appear to be any actual questions for you. A lot of people just saying butt plug. So I want to thank both Q-Op and Phil Bell for a civil debate. But we're going to call it there. Phil, I thank you for your insane expertise, and I am honoured to know somebody that was involved in this mission. Thank you for being part of my life and making me a happier person.
Thank you. I hope to be around a bit longer. You know, I'm having a bit of a struggle at the moment, but
you're strong, dude. Kick that C's ass.
See.
And I was very serious with what I said about if you ever need to chat, feel free to reach out to me in private. All right.
Well, I've got some major surgery coming up, so we'll see what happens after that.
Q-Op, in all seriousness, thank you very much for allowing us to host this debate on your server. I do appreciate it.
Yeah, thank you. That wasn't too bad. That was fun.
It was fun. Thanks very much.
Mod Kitty, thank you very much for looking after the chat and the mod on the side. I do appreciate you as well. We're going to call it a night for the Discord tonight, and I'm going to give CC a quick call because I need to let him know that I know where he lives thanks to Flat Earth Dave's app. So good night, Phil. Feel free to leave the Discord server, and good night, Q-Op and your server. Have a great night.
For nothing. Dude, fuck you, Q-Op. Deadass.
Wow, that was amazing. Going to read some super chats and then give CC a call because CC keeps pushing Flat Earth Dave's app, and I need to tell him something about it. Let me read the super chats. Really appreciate you guys reaching that super chat goal. That was amazing of you. Let me see where we got to. We read that one. We read that one. We read that one. We read that one. Odin's Rage, $5 Canadian says, calmly humming, we love Earth to stay sane. We read that one. Actually, I've read that one already. Stoops the cat. Wait. Gary, Gay Fruit Basket, crate name, says, speaking of Skylab, can Flerfs explain Alan Bean doing gymnastics aboard Skylab in his undies? Yeah, they just attached the cables to his skin, apparently. Stoops the cat actually posted a decent video explanation of the neutrino experiment. Stoops is going to be saved, guys, alright? Might seem a bit arrogant, but I can save him. Bill Tetley, $20. Queue up. You read that one. Thank you, Bill. I do appreciate it. The Flerfinator for $2 says, Queue up has studied nothing yet knows everything. Well, that's flat earthers everywhere, isn't it, really? Randy Lay for $5 says, Queue up is like Demok without the poetry. No depth, no emotion, but just as stupid. Bro, literally, go home, Queue up. Bro, literally, no one likes you, bro. Clemos for $10 says, that slide is fantastic. Can I get hold of it? Send me an email, Clemos, and I will pass those slides on to you that Phil Bell gave. F Grudge for €5 says, he's not arguing anymore. He's a closed system that absorbs all counter evidence. Earth is life for $5. So Q-Op's entire argument is everyone is lying. Whoa, I'm convinced. Rimnivox Spilkerman, $2. Q-Op, the black hole of thought. The Fluffinator of $2 says Q-Op is a lost cause. There's no coming back for him. I maybe agree. F Grudge, €5. I believe you make up Spacetime, so I can make up random shit too. Earth is life, $5. Q-Op, get a globe, put a camera on it, spin around, do a time lapse, then come back and show us the footage. I dare you. You did just send me something like that, didn't you? Let me see. Oh, look. Converging and diverging star trails, exactly what you would expect. Amazing. Thank you very much. Gary IOW, been a member for 34 months, says, I've been around for ages. I still can't believe these people exist in 2026 when they have the some knowledge of humankind at their fingertips. F Grudge for €2 says, phone CC. I'm going to. Clarence for £5 says, Q-Op has added nothing to this conversation. Please make him apologise for wasting everyone's time. Q Continuum for €2. CC, phone home. You Bring Matty Talks says there's going to be an after show. I don't know if I'm going to make that because I'm fucking tired and I have gym in like 6-7 hours. F Grudge for €2 says, if he wasn't in a rocket, the rocket didn't exist. Yeah, that's flat earthers. Q Continuum, €2. Q up, please do not use any LLM to prove stuff yet. Fucking just watch Father Fi on YouTube as to why you shouldn't trust LLMs. F Grudge says, I love Flerfs. You're lying. And then he says, butt plug for another €2. Q Continuum for €2 says, Q to the rescue. First time they've rescued anything. And then Q Continuum says, take my money. Thank you very much. And see if I care. Well, I care. I care that you care. Thank you. F Grudge says, cool CC. I'm gonna. Q Continuum says, cool CC. I'm gonna. Gay Fruit Basket, €5. Your friend CC, Chris in Westchester County, needs a call, Craig. I'm gonna call him. Suspicious Chocolate for $2. I love that Flerfs Are Idiots is back. Me too. I'm totally back into the videos. I'm going to start the script of the next one tomorrow, and that should be out in maybe 4 or 5 days. We'll see. I'll try and get it as quick as possible. I want to release at least one a week. 2 if I can keep up with it. Bill Tetley for $2 says, buy my new official FTFE branded butt plug. I am not selling butt plugs. However, if you go look at the pinned merch, you can actually get the new Copium t-shirt, which is only available for another 27 days.
It's not been possible to connect your call.
Gonna have to hide my number.
Sorry, no one's here to take your call. Please leave your name and number. Thank you.
Shame.
At the tone, please record your message. When you've finished recording, you may hang up or press 1 for more options. To leave a callback number, press 5.
Cece, buddy, I noticed that you keep pushing Dave Weiss's app. I'd like you to know that because of that app, I know your address. I know where you live. Because that app leaks data. Dave Weiss does not care about you and does not care about protecting you or your data. He has, because you are on that app, he has let everybody know where you are. He has literally leaked your personal information. All right. Also, the entire thing has been debunked by Jeranism going to Antarctica. But you really need to understand that that app has left you in a vulnerable position and you should delete it as soon as possible. This is me being nice to you, Cece. Have a great day. Hugh Jar says, living a member for 47 months. I was going to sell Hugh Jar's butt plugs, but given their size, the shipping made it economically unviable. F Garage for €2 says, FTFE branded butt plugs now. Fucking never. Phil Bell for $2 Australian. That was fun. Go Neutrinos. You rocked, Phil. You absolutely kicked ass, and thank you very much, dude. You are amazing. Clive Wells says that you have amazing patience to deal with QOP's denial and obfuscation. Abso-fucking-lutely. Right, guys, I really appreciate you being here with me tonight. It's been absolutely incredible. Make sure you go and watch the new episode of Flerfs Are Idiots out now. It is currently trending 1 out of all of my videos, so hopefully that's going to do really well. But before I go, I'm going to ask a very important question. Can we pretend that airplanes in the night sky are like shooting stars?
Can we pretend that airplanes in the night sky are like shooting stars? Should be wishing for a brain right now, brain right now, brain right now.
Good morning. These words come with a storm warning. Better batten down the hatches, grab some matches and brace yourself for a long day of misery. YouTube has given me the power to reach up into the sky and show you all that we live on the ball. I bring you science that's comprehensible. Your view is indefensible. You're reprehensible. Go on, Mr. Sensible. When I was young, I never thought I would be here to see this. A pile of random nonsense dressed up as bulls. Your ignorance will be the death of us all, like running head first, full speed into a wall. You could always read a book, buy a telescope, set it up and take a photo of the moon, or just be a buffoon. I send you in a balloon up to the stratosphere on page 3.
You're a few fries short of a happy meal. You're dumber than a box of hair. The wheel's spinning but the hamster's dead, and you're as smart as bait. You forgot to pay your brain bill. You're missing a few buttons on the remote control. 24 cents short of a quarter. You're surfing in Nebraska. You're as bright as Alaska in December, and you fell out of your family tree. You don't have all the cornflakes in one box. You got an IQ of 2 and it takes 3 to grunt. The elevator doesn't go all the way up, and there's a vacancy on the top floor. Your antenna doesn't pick up all the channels. You're several nuts short of a fruit
You're Mr.
cake.
Sensible, calm down, don't go too hard. You don't need the hard Siberian flerfs in your backyard. You're a man of science, poison grace. Mage 2 did everything to wipe the grins off the face. So Nathan, get away from those kids. The world is not flat and it doesn't have a lid. Recognize the differences between the textbook and the Bible and control yourself. Lay off your slander and your lies. You're a bunch of knobs poisoning the well of the youth, spreading lies that you like to claim as knowledge and truth. Stop spreading fresh bullshit like the butter on your bread. Maybe your musical assault will knock some sense into your head. I hope one day you'll hear these lyrics and smile, and you realise you used to be a 40-year-old child. Now it's time to wake up, open your eyes and see, and acknowledge the existence of
Gravity. You're a few clowns short of a circus. Your phone is off the hook. Your sewing machine is out of thread. You're all foam and no beer. You don't have all your dogs on one leash. An intellect rivaled only by garden tools. There's no grain in your silo, and your skylight leaks a little. Your belt doesn't go through all the loops. You couldn't pour water out of the boot without instructions on the heel. Your slinky's kinked, and you're proof that evolution can work in reverse. A few feathers short of a whole duck, one fruit loop short of a full bowl.
Airplanes in the night sky are like shooting stars. Should be wishing for a brain right now, brain right now, brain right now.
thought it was over? Well, I'm still standing while you're swinging, flinging feces, talking shit just like the human centipede. You've got the mind of a chimp, and I'm here to expedite your shore leave. Cause I'm a seaman, but not the kind I writ up on your mom's gums. I'm the kind that sailed submarines and fired guns. I could float a boat across the ocean with my eyes closed, circumnavigate the globe with a compass and a bag of sausage rolls. Well, all you can do is nibble on your toes. I'll smack you with the hose that you taught a water level, sit and swivel. You nasal gazing muppet, you can stuff it harder than the wallet stuffed by Warren Buffett. And I don't care about your sauces unless you're serving them. And I don't care about your lines unless you're curving them. Now step away from me, you're sucking up my oxygen with the vacuum where your brain should be, you dumb fuck. Thank you everyone for watching. What a brilliant show, really do appreciate it. Don't leave, stay in the chat and you will automatically be redirected to the after show on Your Brain Matter Talks with our friend Max. In the meantime, remember, stupidity is not a right. Fight the flat earth.